Lesson 4.6. We will solve equations with variables on both sides. Alright, let's see here. First things first. So we get a verbal statement, a verbal question. So here's our context. Sally is making a scarf. She already has 12 inches completed. She sews at a constant rate of 1/5 inch per minute. The scarf must be 50 inches long. While I get set up for a minute, you take a minute and try to write the equation yourself. Just a normal, everyday equation. Let's get the highlighter. Alright. She has 12 inches completed. So that means that part's already done. Okay, she's sewing at a constant rate of 1/5 per minute. Well, the per tells me that it's going to be multiplication, so there better be some multiplication in there somewhere. And the scarf must be 50 inches long. Okay, well that's the total, so it should equal that. Let's see what our equation is. And there it is. Okay, so 50 equals 1/5 x plus 12. We have a constant, we have a coefficient, we have a total. This is just our regular basic equation. Okay, it only has a variable on one side. Let's get a different pen here. Okay. Then you want to isolate the variable. Okay, that's our normal solve it. Okay. So you can see how I've done that. I've canceled my constant on both sides by doing the inverse operation. Plus 12, the inverse is minus 12. Okay, here we go. Minus 12 on both sides. Well, then we get 1/5 x equals 38. Well, how do I get rid of this multiplication here? Or this division problem, I'm sorry. I have to multiply by the reciprocal, which is 5/1. Okay, then you can type that into your calculator. 38 times 5, it would be 190. What does that mean? 190 what? Minutes. It's 190 minutes. That's how long it would take her to do the whole scarf. Now this is review because this is only a variable on one side. The next problem is going to have variables on both sides. But I wanted you to pay attention how we did isolating the variable. Okay? We had to do the inverse operation. We have a variable on one side, we have a constant on one side. Alright, let's look at the next one. 3x equals 2x plus 5. So here's the equation that we're given. This one does have a variable on both sides. Our whole goal is to get a variable on one side equaling one constant, aka the number. So like x equals 5 or x equals 2. You can pause it and try to do it on your own because I'm going to pull the screen down and show you how I did it. Okay? Alright. I have 3 x's over here and I have 2 x's over here. I need them to be on one side. I could do one of two things. I could do minus 3x, minus 3x. That would get rid of my x on the left side and leave me with 0. And then that would turn this negative. I don't know if I want to do that. I could also do minus 2x and minus 2x, which is what I chose to do. Okay? Because when I do that, what happens to these two? They cancel. Okay? And then I'm left with 3x minus 2x's. Well, if I have 3 x's and I take away 2 of them, I'm left with 1x. X is equal to 5. Okay? So there it is. I have a variable on the right and on the left, and I moved them to one side. It's the inverse operation that we have to remember. So x is equal to 5. Now, of course, you need to justify it. Okay? And that's always the big thing. Justifying simply means plug it back in. So 3 times 5 should be equal to 2 times 5 plus 5. 3 times 5 is 15. 2 times 5 is 10. 10 plus 5 is 15. Is that a true statement? Yes, it is. It works. Okay? That's all. We're simply rearranging things, but we have to keep the scale balanced. If we do it to one side, we do it to the other. All right, next one. Here we go. Now it's getting a little tougher. Okay? We have 3x plus 2 equals 2x plus 4. I have constants on both sides. I got 2 over here, 4 over here, and then I've got a variable on both sides. I got 3 over here and 2 over here. I need the variables to be on one side, the constants to be on the other. Okay? So where you start could be a couple different places. I kind of like to do the variables first. Okay? So here again, I want to keep my variable positive, and in order to do that, I'm going to do minus 2x and minus 2x. Here's my imaginary sides that I'm talking about. What happens with these two? They cancel. Okay. Then I'm left with this. I have my 1x. Okay, there's an imaginary 1 there. Plus 2. That 2 didn't change. Neither did the 4, so they just came straight down. Okay. So now I have 1x plus 2 is equal to 4. Well, mental math is going to tell you that x is what? 2. But we need to see how we're going to do that, because eventually they're going to get harder. Again, inverse operation. I need to get my constant on one side, my variable on the other. These two cancel. 4 minus 2, x is equal to 2. The same statement. I have one variable equals one constant. That's what I need. Now, if you would have ended up with 2 equals x, those two are the same thing. Okay? It doesn't matter which side they're on. They're the same thing. X is equal to 2, 2 is equal to x. Again, I want you to justify it. That simply means plugging 2 in right here and plugging 2 in right here. Go ahead and pause it and you do the justification. 3 times 2 is 6. 6 plus 2 is 8. 2 times 2 is 4. 4 plus 4 is 8. Does that work out? Yes, it does. I know I did it correctly because I can check it. All right, last one. I think. Here's another one. I have variables on both sides. I have constants on both sides. This is a hot mess. I need variables on one side, constants on the other. The one thing that is different about this is what property is this using? Good. It's a distributive property. When there's a number outside of the parentheses, that means you have to distribute first. Meaning 2 times 10, 2 times 3x. And we have to do it on this side too. 4 times x, 4 times negative 4. You go ahead and do that. I'm going to pull down the shade and show you. There we go. That's what it comes out to be. 2 times 10 is 20. 2 times 3x is 6x. 4 times x is 4x. 4 times negative 4 is negative 16. Now you got to be careful. Now I have variables here, numbers here. We need to start moving some stuff around on this balance beam. Okay, what do you want to get rid of? We could do minus 6x and minus 6x. But if we do that, what's 4 minus 6? That's negative 2. I don't like negatives. So let's do minus 4x. What happens to these two? They cancel. Here, I'm still left with 2x. That's okay. These things don't change. So I got to bring those down. Okay, here's my new equation. New one. I got rid of the 4x. That's gone. Well, I still got a number over here, a constant. I need to get him on this other side. So what's the inverse of positive 20? Minus 20. I've now made a 0 pair and canceled that. And I also did it on the other side as well. And negative 16 minus 20. Let's see what my new equation is. 2x is equal to negative 36. Now, I've got numbers on one side, variables on one side and constants on the other. I still need 1. I don't want 2x, I want 1x. What is 1x equal to? What's the inverse of multiplication? Good, division. These two make 1. So 2 divided by 2 is 1, leaving me just x. And if I do it to one side, I have to do it to the other. And there it is. X is equal to negative 18. Now what do we want you to do? Of course, justify. You got to go back and prove your answer. Plug that negative 18 in. See if it works. I'm not going to do it for you. You can do that. Plug negative 18 in here, negative 18 in here. Make sure you follow your order of operations, and it should work. If it doesn't, you need to check your math because negative 18 is the correct answer. Here's the final goal. We need one variable equaling one constant. What that means is x equals 7 or x equals negative 3. I have one variable equaling one constant.